Alright, so you should have watched the last video about the properties of logarithms. But this video, I'm just going to go over some examples. So if you did not watch the last video, please watch it. But these are going to be the problems, or similar to the problems that you will see on ALEKS. So this says use the properties of logarithms to expand the following expression. So we want to expand this, meaning we start with one log, we want to end with more than one. So we need to get rid of, the first thing I see, I want to get rid of this radical. So we have the cube root. Notice the 3 is kind of, it's not out in front. This means the cube root of y to the 4th. Well, if you watch the exponential or the rational exponents video, we know that this is the same as y to the 4/3 power. So we're going to rewrite that as log of y to the 4/3 over x times z squared. So we have two things being divided. So this is kind of like the quote. We're going to use the quotient property first. So if you don't know what that is, please make sure you have the notes out. But basically, we can rewrite this as log of the first, or the numerator, so y to the 4/3 minus log of the denominator, so x z squared. And then I'm going to do step by step. This is exactly how I want you guys to do it. If you are getting the problems wrong, go step by step. This denotes multiplication, so we can use our product rule. So minus log of the first quantity, which is x, plus log of the second quantity. And then the last rule, we have these exponents here. So when we have exponents, we can use the power rule. So with this one problem, we've used all of our rules. And the power rule just says we can take that exponent and bring it in front. So 4/3 times log of y minus, this is a 1 here, so we can't really, the exponent is technically a 1, so that's not going to change anything. And then this 2 will also come in front of this log, 2 times log of z. And this would be your answer. So this is how we expand logarithms. This is something that will take some practice, but you guys have problems to practice on. So now this type of problem says write the expression as a single logarithm. You might also see them ask you to condense. So the last problem we expanded, this now we're going to condense. Notice the bases are all the same, so we're kind of going to work backwards this time. First, we want to use the power property, which means all of these numbers in front of the logs we can write as exponents. So we're going to write log base c of w to the 6th power minus log base c of z to the 1/4 power plus log base c of y to the 3rd power. Right? So again, w, z, and y are just variables. They just hold the place of a number, so we treat them just like numbers. So we use the power rule. Now let's try to use the product rule to kind of condense this part over here. So we have log base c of w to the 6th power minus, when we condense, we multiply these two quantities. So we're going to multiply this here and this here. So we get log base c of z to the 1/4 times y to the 3rd. And then this minus sign means we can divide. We can divide this being our numerator and then this entire expression being our denominator. Well, actually just what's under just this part, I guess. So just this. So this becomes if we condense it more, log base c, w to the 6th power over z to the 1/4, y to the 3rd. And you can leave your answer like that. However, sometimes they do want you to get rid of that rational exponent. So you may write it as the 4th root of z. So that's the 4th root of z times y to the 3rd. And this should be your answer. So we just work backwards, really. This problem says fill in the missing values to make the equation true. So we have log base 3 of 7 minus log base 3 of 5 equals log base 3 of blank. Well, when we subtract, we're going to use our quotient rule, which basically says we divide these two quantities. So we just divide these two numbers, right? And put it in next to one single logarithm. So our first answer should just be log base 3 of 7 over 5. Again, we don't have to force anything. If it doesn't, you look at it, you like 7 doesn't go into 5. Maybe I'm doing something wrong. No, follow the rules. Don't make up anything. Don't make it more complicated than it has to be. Second problem, we have this addition. So we're going to use the product property, which states we multiply whatever value this is times this, and we should get 72. So some number times 8 equals 72. You can divide by 8 and get x equals 9. So the second blank should be 9. And then the last one, I'm going to do this in blue. Bases are the same. This 2 in front means that we used the power property. Whenever you see a number in front of a log, we can use the power property. Well, if we reverse the power property, we just put this as an exponent. So this is some number. This is some number that when I square that number, I get 25. Because that 2 is going to become a square. So some number squared will give us 25. Well, to get rid of a square, take the square root, we get 5. So this last blank should be 5. And that's it. All right, and the last type of problem you'll see is one that looks like this. Use the change of base formula to compute log base 8 of 5. Round your answer to the nearest thousandth. Now, you may not have a computer, but I do know that Alex has, not a computer, a calculator. Alex has calculators. So if you press this button here, now this is just a screenshot of the problem, so I can't press the button, but if you press the button, you should see the button that says log, L-O-G. So we're going to use the change of base formula. Log base b of a is the same thing as log of a divided by log of b. So our a is 5, so log of 5. Our b is 8, log of 8. And then we just put that in the calculator. And we get approximately 0.774. So if we put this in a calculator, mind you, the question is asking, this right here is asking 8 to some power equals 5. So 8 to the 0.774 should be very close to 5 because we rounded. And this turns out to be true. So if I got a number that was bigger than 1, let's say we got 1.2 as our answer. Well, 8 to the first power is already bigger than 5. So we know this number is too big. So just try to make sense of the answers that are coming out. Even though you're putting in the calculator and there's no arithmetic way that I'm going to show you to evaluate this, make sense of your answer. This is the extra credit problem. you can work it out and just take a picture and send it to my email for extra credit.